so today what we're going to do, we're going to talk about something called triangle inequalities. So inequalities that happen with triangles. So first we're going to talk about side lengths. So you can't just make up any numbers for the three sides of a triangle and it automatically works. Okay, there is a little bit of pattern and a method to it. So here's what this says. It says sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, here's what it means in English. Let's say this is 3, 4, and 5. I'm just going to make up some numbers here. What this is telling us is that 3 plus 4 has to be greater than 5. So add any two sides has to be greater than the third side. So let's rearrange it. 3 plus 5 has to be greater than 4. Rearrange it again. 4 plus 5 has to be greater, plus 5 has to be greater than 3. Are all of these statements true? Yep. Right? 7 is greater than 5. 8 is greater than 4. 9 is greater than 3. If all three of those statements are true, then yes, this would truly form a triangle. So let's look at something that wouldn't form a triangle. And we'll talk about the why of it, and I think it'll make more sense. I'm going to change this. What if I did 1, 1, and 4? 1, 1, and 4. So is 1 plus 1 greater than 4? No, and we can stop. I don't need to keep checking the other sides because as soon as I say no, we're done. It doesn't form a triangle. So let's think about what this would look like visually. So think about if I had a 4-foot board, okay, this is 4 feet long, and I wanted to make a triangle using this board and 2 1-foot boards. So I put it here, and this is 1 foot, and here, and this is 1 foot. Are those going to reach each other? Okay, probably because I have them sticking in the air. So what if I were to lay them down? So this is 4 feet, and I laid it down further because I have it kind of up in the air. So what if that's 1 foot and this is 1 foot? Do they reach now because they're laying flat? No, I've got a 2-foot gap between them, right? They're way, way too short. Okay, so what if I made it exactly 2 feet and 2 feet? So let's say this is 2 feet and this is 2 feet. Then that right there in the middle. It's still too short, right? It's laying perfectly on top. We need one just to be a little bit longer, just to pop it up, right? Otherwise, it's just a flat board laying on a flat board. Okay, so if this were like 2.1 feet, it would be a little too long, so it would have to pop up, right? Because these two ends have to be anchored, right? If it's going to be a triangle, that has to be my vertex. All right, so that would be enough to pop it up. Now, it's not going to be a very exciting triangle. Yeah, it's going to be really flat, right? An extremely obtuse angle. But that would actually make a triangle. So that's why this rule needs to be followed. So that you can have enough two side lengths that are long enough so they end up popping up. Does that make sense? All right, so now that being said, do we really need to try all three of these inequalities? Which one do we have to do? Which one here? The two shortest. So the two shortest is the one we really have to check. Because if you look at the other two, 5 is already greater than 4. Right? I don't care what I add to it. 5 is still going to be greater than 4. Same thing here. 5 is greater than 3. Well, we're never going to have a negative number because it's a side length. Right? It's an actual measurement. You don't have a negative number on your ruler. Does that make sense? So really, as long as we test the two shortest sides against the third side, we don't have to do all the inequalities. All right, so now you try. Here's 3 sets of sides. Determine if each one is a triangle. So just yes or no. Just write it on your paper. I just wrote it. I'm trying to figure out why they're all no, and then I just realized I can't. Everyone like more time? Okay, how about the first one? Do you need notes? There you go. All right, how about the first one? Does it make a triangle? Yes, because 10 is greater than 8. How about the second one?
No.
No, because 9 is not greater than 10. How about the last one? This is a no as well, because 10 is not greater than 10. Easy enough? Awesome. All right, so now you're going to be working as a table here for a couple minutes. What I need you to do is you're going to be drawing a scaling triangle. So everybody in this room has a scaling triangle. At your table, you need at least one person to make it obtuse, one person to make it a cube, and at least one person to make it a right triangle. Okay? You're going to want to draw it big because we're going to measure all the angles and all the sides. So go ahead and do that first. Draw your triangle, decide who's drawing what kind. Everybody else needs scaling. So we need 2. There should be at least 3 different triangles. Everybody should do this. But one person has to draw on a cube scaling, one person draw on the obtuse scaling, one person draw a right scaling. 2 of them are going to get doubled up. You might need a right angle. You can use the corner of your paper. First. Thank you. Sorry. Some people have to go. It's just the way you said that. It was so cold. No one do it. Okay. Okay, once you have your triangle drawn, please name your triangle ABC. So one angle is capital A, one angle is capital B, the other is capital C. Name your triangle ABC. You have to make the right angles. Okay. So name your triangle ABC. When we're talking about triangles, a lot of times what they'll do is, after they name the triangles, for instance, ABC, the side that is opposite of angle A is side A. The side that is opposite of angle B is considered side B. Those are lowercase letters, and then C is opposite of C. So the sides are lowercase letters, the angles are uppercase letters. We only do this really in triangles. Everybody good? All right, now what I want you to do, I want you to measure all of your sides and angles. Okay, measure your sides in centimeters, and go ahead and just label it right on your triangle. So measure all your sides and angles. Yes. Well, you should only have one triangle. And you're supposed to like share the responsibility. One person makes. Okay, so mine should be just a triangle. So measure all your sides, measure all your angles. Yes, please. You did like points. Like 0.4. I just rounded mine like out. Oh, it'll work. It'll work. Either way, way, it'll be fine.
Like it was like it would have been like 29. I'm like, it's gonna be trouble. That's this is upside down. Like, oh my God.
If it's an acute triangle, all three angles have to be acute. So if it's an obtuse triangle, you're only going to have one obtuse angle and everything else will be. I got one. I got those. I don't know. Maybe another.
Wait, how do I draw a triangle that's not 100? Wait, what's up? Students measure. That's what
Yeah, I'm going to give you about another 30 seconds to finish that up. All right, so next thing, listen carefully for a second. The next thing I want you to do is you are going to list your angle names in order from the smallest to largest. So not the measurement, I want the angle name. Then do the same thing for the side lengths. The smallest side to the largest side. Again, not the measurement, but the name of the side. Okay, so list that in order. You can put it on your notes if you want, or wherever. The smallest to largest.
So I should have a quick one going. Where was we is the measurement or the angle? Yes. Or what we're arranging, is that the measure of the angle? Or
The top one is the angle. The bottom one is for the sides. Yep. Okay, after you're done arranging them, start sharing your results with your group. See if you notice any patterns that happen.
So like one of the smallest angles, I'm gonna have to one. Mine was. Wow. That's right. That's the way you did it. This is why I have to finish. Sorry. Yes. Did you hear it? No. You need to make those. I have mental toughness.
All right, so did you notice any patterns? It's in the same order, right? So if you had BAC up here, so if my angles were BAC, what order is my sides going to be in? BAC. Okay, now not everybody's going to have BAC, right? This order can be different, but whatever is listed first here is going to be first here. Whatever's second here will be second, third, and third. Right? Did that work? Well, then my guess is you measured incorrectly. All right, so what this means for us is, in a triangle, the smallest side is always opposite the smallest angle. The longest side is always opposite the largest angle. The median side will be opposite the median angle. Okay, so think about that logically. If you had a huge wide angle, you're going to need a long piece to go from end to end, right? But if you had a teeny tiny angle, you're going to need a teeny tiny piece to go from fingertip to fingertip, right? Yeah. Okay, so this is going to keep coming back to us a little bit, well, several times throughout the year. Before we do that, anyways, that's what this slide here is telling us. The largest side opposite the largest angle, the small side opposite the smallest angle. So take a second here. I give you two different triangles. List the angles in order from smallest to largest for both of these. Okay, so take a minute and do that. Okay, so what do we get for the first one? What's our order? BAC, and what's the second one? CAD. Is that okay? Questions on that? All right, so the purpose, there's many different purposes actually. One of which is it gives us what's called number sense and the rightness of our answer. So number sense is like when you type in, let's say 2 plus 2 in your calculator, and you get 8,371. Right? Your number sense would be like, hold on, that doesn't seem quite right. Okay, not that you really have to type in 2 plus 2. But do you know what I mean? Like when you get some off the wall answer, you're like, oh, hold on, that doesn't seem okay. Okay, that's called number sense. In geometry, at some point, we are going to be solving for missing sides and angles. So let's say I have this triangle and I have a 32-degree angle and a 20-degree angle. And I saw like if this side is 100 feet and this side is 75 feet. My number sense and knowing this triangle inequality would be like, hold up here, because 20 is my smallest angle, it should be opposite my smallest side. But look what happened here. Right? This is a larger angle, but 75 is not larger than 100. This is one of those things where like, hold on, I probably made a mistake somewhere because that can't be possible. So it gives us a little bit of number sense. So every once in a while I'm going to say, hey, remember that day we talked about the smallest angle opposite the smallest side, largest angle opposite the largest side? Okay, we'll keep coming back to this. All right, the last topic I want to talk about is isosceles triangles. So we know an isosceles triangle has at least 2 congruent sides. Those 2 congruent sides are called the legs. The non-congruent side is called the base. The angles along the base are called the base angles. As mathematicians, we're very creative, right? And we have the base angles, and then the angle between the 2 congruent legs is called the vertex angle. Right, so we're going to refer to those terms. Any questions about that? All right, so the isosceles triangle conjecture says, if a triangle is isosceles, so if we have 2 congruent legs, then the measure of its two base angles are congruent. So if we have two congruent sides, then we have two congruent angles. We can also reverse that. Okay, and we call it the converse. We don't call it the reverse. We call it the converse. So the converse says, if we have a triangle with two congruent angles, then we're going to have two congruent sides, which means that it has to be an isosceles triangle. Okay, so do you remember that day when I talked to you about how the small angles up to the small side, large angles up to the opposite sides, or the largest angle is opposite the largest side? You should all be nodding your head yes, and it was like 2 minutes ago. Okay, so here's one reason this is important. We were talking about listing our sides and angles in order from smallest to largest, right? But guess what? We have a tie. We have a tie for our angles. We don't have a small, medium, and largest tie. So that means if I go to the opposite sides, it's going to be a tie as well, right? So we're not going to have small, medium, and large sides either. So if the angles are the same, the opposite sides then have to be the same. It's part of that triangle inequality. You don't seem nearly excited about this as I do. All right, so you probably knew that the base angles were going to be congruent, right? You're far enough in your math group, that's not a big surprise to you. But I want you to understand why that happens. Does that make sense now? Awesome. Okay, last problem. In this figure here, in this isosceles triangle, we have a 50-degree angle. Is that a base angle or a vertex angle? That is a base angle. Good. What other angle is a base angle? X. Good, because they're opposite of our congruent sides. So that means X has to be 50. And what does that make Y? 80 degrees. Is that okay? All right. So your homework, and I think you actually should be able to get it done. It's on 2 different pages again. The first one is dealing with all the triangle inequalities. Okay, so like think the first 7 are like list the sides in order or list the angles in order. Like small, I think they do largest to smallest. So make sure you can correct it. The second half is with isosceles triangles. Good? Okay, so don't tuck your homework into your book because you will not need your book at all next week. Okay, so put it in a folder or whatever, so then you don't have to bring your homework or your book. Good?